We have a quadratic equation. We're going to talk about inverses of a quadratic and see what happens when we try to find them. If I were to graph x squared plus 5, we have a quadratic that is shifted up 5 units and is opening upwards. So we have a quadratic drawn. If I were to go and switch x and y and solve for the inverse, I end up with x minus 5 equals y squared, and y equals the square root of x minus 5. However, both a positive and a negative of the square root of x minus 5 would be needed. So if I were to graph that on our axis, my previous video said that when I'm graphing, I can just take the points and switch them. So without actually finding this equation, I can still graph it. Our vertex was at the point 0, 5, so now we're going to be at the point 5, 0. This point right here is 1, 6, so it's going to become 6, 1. We have the point negative 1, 6. So that's going to be 6, negative 1. We also have the point 2, 9. So we have 9, 2. And we have negative 2, 9, which would be 9, negative 2. And when I graph this, you'll see what happens. I am reflective over the line y equals x. So you can see that I'm going to sketch that in for you. But the problem that we have right now is that our inverse would not pass the vertical line test. So our inverse is not a function. And that is because we have both the positive and the negative. The upper part is the positive square root of x minus 5, and the lower part is the negative square root of x minus 5. You would have to, if you were to graph this in your calculator, enter in two equations, one that just has the square root of x minus 5 and a second that has a negative out front, and it would actually have to be graphed in two parts. So in this case, with our quadratics inverses are not functions. We may care about them being functions. And if we do want them to be functions, we are actually going to have to change the problem from the beginning. Problem is I have essentially, imagine this kind of your arms up in the air. You have two arms to start. So when I find the inverse, I have to draw two arms. But the problem here is that having two of them is what's not allowing us to pass the vertical line test. So if I needed the inverse to be a function, I would have had to start off from the beginning with my x squared plus 5 and not including the entire domain. I can't include from negative infinity to positive infinity. I would have to include from my vertex over to one side and only draw half of it. Typically, you would draw the right-hand side, but it's not necessarily always. You technically could draw the left-hand side, but normally you would draw from your vertex to the right. So when I would have had to start the problem, I would have had to say y equals x squared plus 5, but only use the values that are greater than 0. If that is the case, it would have altered my picture. I would not have drawn this left part. And therefore, when I found the inverse of it and I had the square root of x minus 5, I would not put out both a positive and a negative in front of the square root of x minus 5. In this case, since we are what we call restricting the domain, I'm only including one arm of the parabola. So the inverse would only have one square root, and the graph that I would draw to have the inverse would only have one side the positive square root, and I would therefore then pass the vertical line test. So if I need the inverse to be a function, we would need to restrict the domain from the beginning. If I don't care if the inverse is a function, and I just asked you for the inverse of the square root of x squared plus 5, you would include both positive and negative square roots.